So in previous videos, we've looked at getting information from different forms of quadratic equations. Now we're going to do the opposite, and we're going to take information and get the actual quadratic equation. Now you can imagine that depending on the information that we're given, we use a different form. So we're going to do a few examples on the whiteboard here, but we're going to note down what information is given for each one, and then we're going to choose a form that is associated with that information. Now the first one is pretty straightforward, you'll see, because we have a quadratic and the turning point is given at 2, -1. Now, of course, as the name suggests, we should use turning point form for this specific equation. But the thing is, we can't just simply use another form. We have to use specific forms depending on the information. And that's because some information can only be put into one form. So for example, turning point, that can only be directly put into turning point form. If you try to put into the other forms, it's actually going to be really difficult. So that's why we need to really focus on what information is given and choose the appropriate form for that information. So in this case, we know it's a quadratic. Now, obviously this is quadratic equations section in the online coursework, but it's really important to note that this is actually a quadratic equation, because if it wasn't, then this process would actually go out the window because we don't know what function degree it's going to be. So for example, it could be a cubic, it could be a quartic. We have to really keep note of the exact form of the equation that we're dealing with. So we have a turning point at 2, 1, so that's one piece of information, and it also passes through the point 4, 5. That's the second piece of information. Now what you'll note is that for quadratic equations, you usually have 3 parameters that you're trying to solve for. So if we imagine the expanded form, y is equal to ax squared plus bx plus c, usually we have 3 unknowns, which requires 3 pieces of information. So one piece of information helps us find the a, one piece of information helps us find the b, and then the third is for the c. Now in this specific case, we're actually only given 2 pieces of information on face value, and the reason for that is because the turning point is kind of like 2 pieces of information, and you don't really have to understand why for now, but once you go to differentiation, it'll make a bit more sense as to what the turning point is actually doing. But if you just want a quick summary, the turning point not only tells us a coordinate that's on the curve, but it also tells us where the gradient of the curve, or like the flatness of the curve, is 0, because that's where the graph turns. So if you've done differentiation in year 11, like let's say if you're in year 12 and you've done differentiation in year 11, you will know that the turning point has a gradient or a derivative of 0. So that's where 2 pieces of information comes from this one line. It's that you know one coordinate, which is 2, -1, and you also know that the gradient at x equals 2 is actually equal to 0. So that's how that line here, or that dot point here, gives us 2 pieces of information, and it's why we don't actually need as much as compared to, let's say, other information that's given, which we'll go through in the next part of the video. So as I said, the turning point is given, so it's really obvious that we need to use the turning point for this specific example. So what we're going to do is just write down the generic turning point form, which is y is equal to a outside of x minus h squared plus k. Now straight away, we know the h and the k value because that's directly related to our turning point. So I'm going to substitute that in. I'm going to say y is equal to a outside of x minus 2 squared minus 1. Again, note that the x is the opposite sign, but the y value is the same sign as it should be. Now, what you can see here is that we just have one unknown and we're given one extra point, which we can kind of think of as our anchor point. So what we do is we just substitute in that point, and that'll give us the a value. So substitute in 4, 5 and just working out really neat. So 4, 5 with an arrow to indicate substitution. 5 is equal to a outside of 4 minus 2 squared minus 1. Now what we need to do is just rearrange for a. It's pretty straightforward from here. So I'm going to move the 1 to the other side. So that's going to become 5 plus 1, which is equal to 6. A multiplied by 4 minus 2, which is 2, and that's squared, which becomes 4. Therefore, a is equal to 6 divided by 4, which is equal to 3 over 2. So therefore, our final equation is y is equal to 3 over 2 outside of x minus 2 squared minus 1. Now, because we chose the right form from the start, this question is pretty straightforward. Because we're given turning point form, we can put it straight into because we're given the turning point, we can put it straight into turning point form and solve this pretty easily. But knowing which form to use, depending on the information, just comes out of practice. So we're going to go through the next example, and it's going to be really obvious what form to use. It's going to be x-intercept form, but just keep in mind that the question is not going to be as obvious in terms of what form to use. It's not going to tell you, like here, I am here to tell you, but in the stress of a test situation, it might be a bit hard to remember. So that's where repetition and practice really comes into play. In this example here, you can see the information given is slightly different. So we have a quadratic, and it's known to have x-intercepts at -2 and 1, and then an external anchor point at 3, 5. So just based on the information given, you can see that we need to use a different form. We're obviously not going to use the turning point form for this, but again, technically we can. You just don't need to know how to do it, because it's much easier just to put this straight into x-intercept form, which looks something like this, where we have y is equal to a outside of x minus b outside of x minus c. Those letters aren't really standard. I just went in alphabetical order, but you can use any parameter that you want. So we're going to straight away put in the x-intercepts. So we'll say y is equal to a outside of x plus 2 outside of x minus 1. Just keeping in mind that you swap the signs for the x-intercepts. Now what we need to do is just substitute in the external anchor point 3, 5, and that'll give us our a value, or our dilation. So 3, 5 you substitute in, so you get 5 is equal to a multiplied by x plus 2, which is equal to 5, multiplied by x minus 1, which is equal to 3 minus 1, which is equal to 2. Cancel out the 5 on each side, therefore a is equal to 1 divided by 2. So our final equation is that y is equal to 1/2 outside of x plus 2 outside of x minus 1. I forgot to mention this in the previous video, but this question is just asking for the equation of our quadratic, but it doesn't specify which form it needs to be in. So usually I just leave the equation in the form that I've solved it in. So for example, this is in x-intercept form. I don't need to expand it unless the question specifies to. Most of the time it doesn't, and I've never encountered a question where it does, but you know, it's a potential option that the teacher has or the examiner has to test your knowledge. But if the question just says find the equation, then leave it in the form that you used. But now that I think about it, there's sometimes been the case where you try to find the equation and then it says determine the values of a, b, and c, when it says to put into the form y is equal to ax squared plus bx plus c. So if it specifically asks for the a, b, and c values, let's say if it was asking for this form and the a, b, and c values, then your final line of working out has to be a is equal to blah, b is equal to blah, c is equal to blah. So just make sure you answer what the question is asking for, but the process remains the same for most of these questions. Now for the final type of information that we're given, we have 3 random points that don't have any significance. So for example, we don't know that any are turning points, and we also don't have any x or y intercepts. So we just have 3 random coordinates here. Now a lot of students would struggle with this because they wouldn't know how to actually solve this. Now I'll be honest, I've never actually seen this on a SAC or an exam, but I have seen it in textbooks, and without the calculator, this is actually pretty hard. It is possible, but you'll see why it actually gets really difficult. So what I'm going to do is set up the equations by hand, and then we're going to transition over to the calculator and show you exactly how to solve it in the most efficient way. So in this case, a quadratic is known to pass through the points 3, 5, 1, 2, and 6, 10, and we're asked to determine the equation. Again, there's no significance about these points. None of them are x-intercepts or y-intercepts, and none of them are turning points either. So what we do is we just use our normal expanded form. To be honest, you can actually use any form, but I just like to use expanded because it's the easiest to remember. So y is equal to ax squared plus bx plus c. So what we do is we set up 3 equations with our 3 pieces of information. So the first one is going to be 3, 5. What I do is I say 5 is equal to a multiplied by 3 squared plus b multiplied by 3 plus c. And we do exactly the same thing for our other 2 coordinates as well. So we have 1, 2. So we'll say 2 is equal to a multiplied by 1 squared plus b multiplied by 1 plus c. And then we do it for our last point. 6, 10 is equal to 10 is equal to a multiplied by 6 squared plus b multiplied by 6 plus c. And what you can see is that we've now created 3 equations with 3 unknowns in total. So you can see we have a system of linear equations that we can solve for either by hand, which again, because there's 3 equations, is going to take a long time, so we'll do it on the calculator. But as long as we set up our working out, then we can just transition to the calculator to actually solve our system of linear equations, which is what we call it. So what I'd say is just label the equations, and then we'll transition to the calculator and show you exactly how to solve this one.